Hello, welcome to part 2 of the lecture. In this part, we are going to discuss uh, some problem that we couldn't discuss last time. So in this problem number 6, we want to find the Taylor expansion for f of x equal to cosine of x about pi over 2. So Taylor series have the following form. F of x equals to f of c plus f prime of c, f prime of c, x minus c plus f double prime of c, x minus c squared over 2 factorial, if f triple prime of c, x minus c cubed over 3 factorial, and it goes on. So here I have my f of x equals to cosine of x. That means f of pi over 2 of that is going to be equal to 0. F prime of x is going to be equal to negative sine of x. F prime of pi over 2 is equals to negative 1. F double prime of x equal to negative cosine of x. F double prime of pi over 2 is equal to 0. F of triple prime of x is equals to sine of x. F of f triple prime of pi over 2 is going to be equal to 1. So my Taylor series would look something like this. F of x equals to negative x minus pi over 2 plus x minus pi over 2 over 3 factorial minus x minus pi over 2 to the fifth divided by 5 factorial plus da 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 da. So that is what we're going to get. So working with the binomial series, so if you have a plus b raised to the power of m, the expansion of that would be a raised to the power of m, m, choose 1, a raised to the power of m minus 1b, m raised to the power of 2, m plus m, choose 2, a raised to the power of m minus b times b raised to the power of 2, and so forth. So this is called the binomial theorem. So m choose k is going to be equals to m factorial divided by k factorial times m minus k factorial. So this is how a binomial series look like. So in this right now we are going to solve this problem, which is a binomial theorem problem. And so using what we just discussed, we want to find the Maclaurin theorem, or Maclaurin series out of that. So Maclaurin series has the following form: f of x, f of 0 plus f prime of 0 x plus f double prime of 0 x squared divided by 2 factorial plus triple prime of 0 3 factorial x cubed and so on. So at this point, we are going to find out the Maclaurin series for that function. So my function f of x equals to 1 plus x raised to the power of m, and then f prime of x is going to be equals to m 1 plus x m minus 1 f double prime of x going to be equals to m minus 1 1 plus x m minus 2 so m minus 1 m minus 2 1 plus x m minus 3 and so forth. So when we evaluate that, we're going to get, so f of 0 would be equals to it's going to be equal to 1, and then when we evaluate f prime of 0, that would be equal to m f double prime of 0 is going to be equal to m minus 1 triple prime of 0 is going to be equal to m minus 1 m minus 2 and so forth. So if we go to f of n of 0, we're going to get m minus 1 m minus 2 up to m minus n plus 1. So then Maclaurin series would look like this. F of x, it's going to be equals to m choose 0 x raised to the power of 0 here plus m choose 1 times x plus m choose 2 x squared plus m choose 3 x cubed and so forth. So then in a compact notation, this would look like k goes to 0 up to k equal to 0 up to infinity of m choose k x raised to the power of k, and that should be the end.